applications. Event-driven is the way you're going to go, and this is going to explore all the kind of things. So yeah, register today. Early bird tickets are available, I think, until mid-August, something like that. So yeah, get your tickets. It'd be great to see you. Also, the serverlessland.com learn page has been updated. Serverlessland.com is all things to do with AWS serverless. We've got learning paths and workshops and coding examples and sort of everything. And the learning page has got a nice new categorization thing, which helps you find a whole bunch of guides. If you're doing want custom info about custom optimization, that's been added recently. Java replatforming has been added recently, and a whole bunch of kind of things. And because I am hosting the stream, I've actually done a whole course on Lambda fundamentals. So if you're actually exploring Lambda, or you've got people who don't quite understand how Lambda works, this deliberately starts at the really beginning and takes a sort of slow approach to understand serverless, understand Lambda, the features, what you can use it for. And it's sort of 23 videos I've put together. So hopefully that'll be useful for people who look at all the information about Lambda on the web and are a little bit overwhelmed. That's the last week. This week and going on, we are talking to Maxime, as we mentioned. We're talking about benchmarking Lambda cold starts. So, Maxime, over to you. What would you like to tell us about benchmarking Lambda and cold starts?
Yeah, thank you. Once again, I'm really excited to be here. So yeah, today we are going to talk about cold starts, and cold starts are really important in some use case. Sometimes it's not that important, but let's say it's important for a use case. And I find it really hard to find like up-to-date information about this kind of information. How long does it take to start your own Lambda function? There's a lot of blog posts about that, but AWS is doing a lot of good stuff to improve the runtime. So yeah, I decided as a side project to create like an always up-to-date, like all runtimes, RRM, x86, different kind of architecture, different kind of memory size. And yeah, I'm going to talk about how I build it today. So yeah, that's it.
Excellent. So, I mean, just to start at the beginning, when you were talking about, are cold starts important or not important for you? Can you just unpick how you think about cold starts and when they are and aren't important?
Yeah. So let's say you have like I don't know, like I'm a big fan of pizza, so all my examples are about pizza. But
let's say you were in Naples recently. I forgot to mention you were in Naples recently doing a course on how to make pizza at one of the sources at Naples. That must have been cool.
Yeah. My passion started during the pandemic. I had free time and I decided to go deep into like pizza making. And yeah, like going into Naples, the hometown of pizza, was maybe the final step of this journey. Yeah.
So Eric Johnson would always want to ask, is pineapple allowed on pizza?
Oh no, definitely a no-go. Definitely a no-go. So no, please don't do that.
What is your most interesting pizza topping then that you like?
Yeah, to be honest, I'm a big fan of like the standard margherita. So fior di latte, basil, San Marzano, pomodoro, tomatoes, and that's it. Chicken is the best pizza hot takes.
Oh dear. Yeah, here we go. We're going to get more information. Pizza hot tapes. Absolutely, AJ. Actually, when I was growing up in Cape Town, South Africa, a common pizza which we all loved was actually bacon and banana and a little bit of feta as well. Yeah. You may think it's weird, but promise you that's my secret pizza.
I'm also a big fan of banana bread, so banana on the pizza. I'm not sure, but you know what? I'll send you a picture.
Cool, excellent. So we got wildly sidetracked about pizza, but that's always a good thing to be sidetracked about pizza. Yeah. So yeah, you were saying about cold starts, whether they were important or not, and pizzas came up.
Yeah. So let's say you're a pizza owner and you have a pizza store, and you are tracking like orders. And if like a customer is following their order status on the pizza, and they're waiting like too long for a cold start, that may be an issue. So if you have like a web application directly client facing, cold start might be an issue. It does not appear that much, but still, like I remember you talking about like 1% of the time, or a bit less than that.
Yeah, even less than 1%. If you think about it, from my perspective, cold starts are only really possibly important if you've got a synchronous connection. So request response where someone's waiting for something.
Yeah.
If you're doing anything that's event-driven, anything that's asynchronous, so that includes anything of SQS or a queue or Kinesis or Kafka or Event Bridge, or a whole bunch of step functions or a whole bunch of stuff, cold starts really don't matter. they're there could be a cost perspective to it, but from a performance perspective to it, doesn't matter at all. So already anything that's asynchronous, we can sort of push to the side, doesn't matter.
Yeah.
So of course it's only synchronous things, and it's going to be front-facing websites and all those kind of things. But the interesting thing, and what Maxime is alluding to, we actually met in Paris at Serverless Days Paris, which was a great event, and I was talking about Lambda and scaling. And the thing is, as Lambda scales up, you actually get less and less cold starts, and it's this interesting phenomenon that developers are developing on your laptop or your workstation, and you push a new version of your Lambda function, goes up to Lambda, and you get a cold start. You push another version and you get a cold start, because every time Lambda updates code or configuration, it's seen as a new sort of artifact, and off you go and get a cold start. So developers are like, help, this is going to be crazy when it scales up into production. But actually, the inverse is true. The higher throughput your Lambda function has, the more concurrency, parallel invocations. You'll have one cold start per sort of concurrent invoke, and then the following ones are going to be warm starts. And across all of sort of Lambda we see, and even speaking to customers, I mean, a really big customer who's a massive Lambda user, they combine their synchronous and their asynchronous cold starts, and they're a huge EventBridge user. So, that wouldn't even matter. And while I was in Paris, I was chatting to him, and he was saying that 1 in 1,000 Lambda invokes is a cold start. So 0.1% of all invokes is a cold start. And so, I mean, that was across synchronous and asynchronous anyway. So yes, cold starts can be important. Yes, you should optimize them, but think about, how relevant they actually are and do what you can for that. But, cold starts isn't the big sort of hot topic issue that everybody was worried about a number of years ago.
Yeah, definitely. So yeah, that's why I started to say by saying like cold start may be important in your use case, maybe not. If you're looking like to improve your P99 or P99.9, the topic would be for you. But otherwise, I totally agree that they happen less and less. So yeah, definitely.
So then, in terms of the cold starts, there obviously Lambda has a whole bunch of different runtimes, and there are managed runtimes and custom runtimes.
Yeah.
Take us through sort of different runtimes, cold starts, how they impacted, and then introduce us to your project, which is awesome, which just keeps us on our toes in a way, which is awesome.
So long story short, like if you're into like performance, maybe it's better to choose non-managed runtimes, so provided runtimes. This way you can own and develop your own Lambda runtime, conform to the Lambda HTTP runtime, so request to /next, /answer, /response, and so on. So if you're using Rust or Go, the binary is extremely small. And like the amount of bytes loaded into memory is a big factor for cold starts duration. So the bigger your binary will be, the longer the cold start will be. So that's one major factor of your cold start duration. Another factor, if you're not using like binary language such as Node.js or Python or even Ruby, is the amount of dependency you're loading outside of the handler function, of course. And I think AJ just gave a really good talk about how to lazy load and outscope the number of dependency that you need at startup. So I would highly recommend everyone to watch it. But yeah, basically size of the binary, size of the package as well, because during a cold start, AWS has to download your code. It's not fully documented how it's happening, but I guess this part is really well optimized. But once again, when a dependency will be loaded, it takes some CPU time, IO time. So the bigger the number, the dependency you have, the longer the cold start will be. So yeah.
Cool. So thank you. AJ was talking about. I'm right here about the concurrency. Interesting. Why is Bob not allowed? I don't know why Bob not is allowed, but JVM is best with a smiley face. But I just wanted to bring that up because there are some languages like Java which are going to have a slower cold start. Well, can have a slower cold start time. We'll go into ways to mitigate that because it is loading a whole Java virtual environment. But then once it's going, Java is incredibly fast. Yeah. So I think these are other nuances that we need to take into account.
Yeah. Plus, AWS has released snapstarts lately, and obviously, you will know better than myself. But of course, snapstarts is a great idea to reduce cold start duration also. It might not reflect on the tool because I'm only talking about like hello world, but for a more complex Lambda function, enabling snapstart would be great. And
so if you don't know, snapstart is basically we load up the JVM, and then we take and whatever application code you need, and then we basically take a snapshot from that. And so when we restore the micro VM, which is a little mini VM that Lambda runs in, instead of having to copy all of the binaries and start up the whole JVM, we literally just restore the whole working little mini virtual machine, and that will be under a second, could even be 100 milliseconds. So your Java cold start before could have been many seconds, and that can be under a second, and it's just a cool, easy way to, without any code changes or very little code changes, just speed up your Java apps. And snapstart is for Java only.
Yeah. And another way to improve your cold start duration would be to switch for x86 to ARM. If you're using like non-compiled language such as Node.js, Ruby, Python, and you don't import like any shared object library, it's literally like a one-click or a better one-line change in your infra's code tool. If you're using Go or Rust, of course, you need to think a bit more about that, because you need to compile it for a different architecture. But yeah, for like Node.js and Python is obviously the most used language for AWS. Lambda. So yeah, if you want to save a bit of money and of duration, you might want to switch to ARM as well.
So is that just from, because ARM Graviton 2 is sort of optimized for the cloud, and so it's slightly cheaper, and it's got some sort of better CPU processing, and so you could just save some money and do little things quicker. So that's a good example. But your previous comment of, so is the sort of big picture is try to make your Lambda functions as sort of lean and mean as you can, really. Remove any dependencies you're not using. Don't install libraries, don't load classes, don't do stuff you don't need to do, and that's gonna help with cold starts.
And also like single responsibility principle would be a great idea as well. Let's say you have I'll take another pizza example, but let's say you have one Lambda function to order a pizza, or one Lambda function to retrieve a pizza. Of course, you can just combine those into one single Lambda, but maybe those two Lambda functions would need two different dependencies, one for, I don't know, like a Redis cache, and one other for DynamoDB, or like, let's say it's two different sets of dependency. If you have two different Lambda function, well, each Lambda function will collect its own subset of dependency, and the cold start duration will be lower. If you want to put like a big express app into one Node.js Lambda function, maybe that's not the best idea to have like a very fast cold start. It might be easier to deploy, but there is some great tooling to do that. So I would suggest just do one Lambda function per mini feature. It does not really matter if you have 2,100, 1,000 Lambda function, as long as you have a big, strong CI/CD and release process, it should not matter. So it's a bit harder to put that in place, but the performance gain is really huge.
Yeah, and I suppose we can also be practical with that as well, that you can slice and dice Lambda functions infinitely, and Lambda functions are, always getting easier to manage at scale, particularly, as you said, with CI/CD pipelines. But, if that's maybe a bridge too far at the moment, then maybe think of grouping your Lambda functions by their dependencies. And so, if you've got, a huge express function, and you are reading and writing from two different databases, even if you split it into two different Lambda functions, which write to the two different databases with the two different dependencies, that's at least going to be an improvement. And then you can further optimize if you need.
And I will play devil's advocate, because I'm a big fan of Lambda function. But if you feel like most of the code should be like together, maybe Lambda function is not the right service for you. Maybe App Runner would be a great choice for you. So don't use Lambda for everything. If you feel like features should stick together, they scale at the same pace, and maybe Lambda is not the right tool for you.
Yeah, definitely use the right tool for the job. And another actual helpful tip which is interesting to get people to think about, is being able to split up some of your code between the synchronous user-facing code and the asynchronous code.
Yeah.
And so often you'll have a user-facing component that returns something to the front end, maybe web, maybe mobile, maybe sort of some SDK call. But then that same Lambda function then does some auditing code, or writes something elsewhere, or sets or writes something else. And if you can do that part, if you can split that part into into an asynchronous processing, even if it's another Lambda function, that's certainly going to speed up your overall processing time.
Yeah, and you gave a really good example about, like, let's say you have like an API for a mobile or a website. Well, the HTTP gateway can filter and redirect to 2 different Lambda functions depending on the user agent, let's say. So if user agent is ABC, go to Lambda A. If otherwise, go to another Lambda function. So that would be a great thing to do if there is a big difference based on the user agent or on the user ID or every other things.
Yeah, and that's also not just performance. You're also thinking about availability here. If one of those downstream dependencies is having an issue, as soon as you switch to an asynchronous model, well, you've saved yourself. The synchronous calls to the front end are going to hopefully continue, and the asynchronous processing can then kick back, continue processing when some sort of error has been resolved.
Yeah, and it's also following best practice for like main software engineering. So if you have like single responsibility, share responsibility. So it's not because like it's super simple to deploy like a hello world, a Lambda function by 3 lines of code, click deploy, it run, boom, it's working. Serverless is still engineering, so you should follow like best practice. Like sometimes I have the feeling like since the entry fee for serverless is really, really low, it's super simple to do like very complex stuff. But sometimes you just need to maybe think a bit more about the overall architecture just to make sure that it scales well, the performance are okay, and sometimes it comes back to best practice in software engineering.
Cool. Well, I've definitely been talking way too much. So, Maxime, can I share your screen, and then we can have a look at the tool.
So I think this slide is now useless because we talked about that. Maybe one fun fact. I used to live in France, as you can hear with my super accent. But I moved to Canada. It was supposed to be a 6 months trip for study. But I fall in love with Montreal, and it's been a bit more than 10 years. So,
Well, that's a point, because I know Quebec obviously is very keen on ensuring that the French language and the English language need to coexist in a lot of things. So when we're talking about serverless in Quebecois, do you have to speak about serverless in the French term, and what would that be?
Yeah, that's super funny. Usually Quebecois are really keen on French, so you need to translate anything. So serverless would be sans serveur. But to be honest, for those kind of super techie stuff, like if you're Googling like sans serveur, it's not going to lead to anywhere. Sorry, Quebec. But sometimes I feel it's better to use the English word for such specific things. But let me go back to the slide. So today is about like building coldstart benchmark using Lambda. So it's a bit of an inception, and we will see that in a minute. So I'm not going to talk about coldstart because we already talked about that. But when an event is coming, so remember Lambda are obviously event driven. So an event will come to a Lambda function, and the first time, or when you have a big spike of traffic, some step would be necessary before accessing to the handler code. So the first one is download the code. AWS is ending that for us, starting the environment. So it will spawn a Firecracker VM. And then we have code initialization, and finally code handler execution. So this is for warm starts, for a cold start, sorry. And the second or sub-second calls, we will be in the like 99.9% of the case, which will be the warm start. So let's see on those yellow box, what can we do to improve that or to measure that? So let's have a look at the demo. So this is my top CSS skills. So sorry about that. I know the visualization is not perfect, but this is the best I can do with CSS. So this web page represents 10 cold starts. So each yellow box is a cold start for every runtime. So
can we just zoom in a little bit?
Oh yeah, sure. Is that better?
Even a bit more if you can. I know
Yeah.
it probably looks weird on your side, but
like this?
Yeah, yeah, I think that's better. Then we can see the runtimes.
So yeah, as you can see, each box is representing runtime. So Rust is winning, as I spoiled that during the intro. But yeah, Rust is compiled, very memory and memory efficient. So the memory footprint is really low, and the cold start is really fast. Obviously, it's just Hello World. Why Hello World? Because it's easier to compare Hello World with Hello World. No dependency implementation detail and so. So yeah, you can modify the memory function, and I recently added the ARM64 support. So this website is updated every day, and yeah, let's see how it works. Yeah, we talked about that. AWS is doing performance improvement over time. So if you go like back in the timeline, performance were maybe not that good, but the aim of this tool is to have like always up-to-date information. So, and it was, to be honest, a fun project to do. 100% serverless, Lambda, DynamoDB, S3. So yeah, why not? So how it works? How does it work? 3 steps. First, we need to invoke Lambda function, make sure it's a cold start. Then AWS is producing this report log line. So every time you invoke a Lambda function, there will be a report log message. And this is great because, as you can see, during cold starts, the init duration will be reported. So I'm not doing some strange math stuff, and I'm just taking what AWS is giving to us, which is the init duration, and that's the source of truth. So the timing you see here is literally the mean or the average of 10 cold start invocation. And finally, we need to display it. So this is the overall architecture, and we will dive into that. But yeah, first step is to actually have the code for each runtime. So a hello world in Java, in Ruby, in .NET, in every runtime. Then we will deploy Lambda function for each runtime. Then we will invoke those Lambda function. And when we will invoke those Lambda function, the report log line will be produced. And this will feed an event to the report log function, which will read this report log, store that in DynamoDB. And finally, the result builder will read those data and produce the JSON that the website is using. So let's dive into that. So yeah, first component is a S3 uploader. So if we have a look at, by the way, this tool is totally open source. So if you click on the how does it work here, you will be redirected to the GitHub repo. If you like it, you can put a little star. But yeah, it's really open source. The aim of that is to benchmark cold start. So if there is a mistake, everyone should be able to detect it and contribute to make it better. So first is the S3 uploader. We have a manifest JSON. So this will list every runtime. So every memory size here, every architecture. I got a bit optimistic and put in an array. So maybe someday we will have another architecture. Maybe not today, but we never know. And yeah, so all runtime are here: Python, .NET 7, Go, Java, Java 8, Ruby. AWS recently released Ruby 3.2, so it's already available here. And yeah, if you want to contribute and add a new runtime, super simple: create a PR, add a new item on this array, and then on the runtime subfolder, you can see, for instance, Node.js. This hello world, super simple. As I said, no dependency, just returning 200. Obviously, for Node.js is super simple. For .NET, it's a bit more complex, but it's still a hello world, status code 200. So yeah, usually it's really simple. Everything is Dockerized, so we can build it for ARM and x86. So yeah, this is the S3 uploader. So we have an application here. We loop over every runtime, and what we do is we send to S3 this package. So under the hood, we have the S3 packet here, Lambda perf. We have every runtime here, and for each runtime, we have the RM version and x86. So yeah, every day we deploy it via a GitHub action, upload S3 buckets, we run the workflow, it's running automatically, and everything is compiled and uploaded to S3. So this is the first step.
So this is every memory, well, not every, a select number of memory configurations for every runtime in both architectures. So,
yes.
So how many Lambda functions are you running on a daily process?
That's a good question. And
Times 10.
Yeah. So let's have a look at US1, which is a production. And we have 167 functions. So for instance, as you can see, 4 hours ago, deployed Python 3.9 version 128 memory and x86, the same for ARM. So 167 minus some personal Lambda function that I used to have, but yeah, about 160 function, which will be invoked 10 times each. So it's not huge, but it's still interesting. So yeah, this is the first step to actually deploy the function code to be ready to deploy, and the second step is to actually create those Lambda function. And I have a live demo for you, so I'm going to switch back to the sandbox like testing account. So as you can see, I have only 6 functions, and one of the function is deployer. So let's run it. Obviously, you don't invoke Lambda function like that, but for a talk, it's better to do that. So let's go back to the function, and if we refresh, as you can see, functions are already being created. So 14 function, no 22, 28, and so on. So what's going on here? We loop over all runtime thanks to the exact same JSON file. We download the artifact from S3, and we create a Lambda function from a Lambda function. So this is why it's a bit inception, but we need to be idempotent as well, because 167 function in like 1 second, we will burst the rate limiting quota. So we need to have some retry, and everything is done every day. So we need it to be idempotent. So if we look at the code on the function deployer, I will resume a bit. So yeah, first step is to delete the function, update the function, create the function, wait for active, get function, publish version for a snapstart. We delete the load group every day. We recreate the load group. So yeah, at the end, if we look at the main handler, it's deleting the log group, creating the log group, creating the subscription filter, deploying the Lambda function. So yeah, very simple code. So the Lambda function is receiving a client context as like an event, and then depending on the context, deploys the Lambda function. So this is a function deployer. Then we need to invoke the function. So there is another Lambda function, which once again loop over the exact same file and invokes the function. Or to make sure that this is a cold start, because as you said, Julian, as soon as one Lambda function will be invoked, subsequent code will be warm. So we need to make sure this is a cold start. And the example you just told a bit before was to update, for instance, environment variable. So this is exactly what's happening. So if we go back to Lambda perf, Lambda invoker, and as you can see, to update, we update the function between 2 invocation, and we update the function by creating an environment variable, which is coldstart, and it's a math random. So by updating that, we are making sure that the next call will be actually a cold start. So it's a bit tricky, but it's just to emulate like a big spike of traffic or configuration change. So cool. Now we invoke our function. So our project is almost done. We invoke function. Now we need to read the report log line. And remember, Lambda are event-driven. So as soon as an event is coming to Lambda, the Lambda wakes up. So it can be HTTP gateway. It can be a direct invoke, synchronous, asynchronous. But it can be also like when a log is written to CloudWatch. So as soon as the report log is written to CloudWatch, this will trigger the subscription filter and wake up the report logline function. So once again, let's have a look at the code. There is a report log processor, app.js, and it's not pretty, but this is a big regexp. So as soon as we see this kind of pattern, we can extract the request ID, duration time, build duration time, memory size, and all like piece of information contained in this report log line. And finally, what we do is we store that into a DynamoDB table. So let's have a look at that DynamoDB table.
So apologies for whenever we update the report log line and mess up your lovely regex.
Oh yeah, but fortunately it didn't happen yet. And yeah, I think it's quite a big change. So hopefully AWS won't do that without a big warning, because I guess I'm not the only one using that. And to be honest, at Datadog we're also parsing this report log line. So please don't break it.
I'll make sure we try not. We don't.
So yeah, as you can see in this table, the first 300 item, we have the request ID, the architecture, the build duration, the display name for the UI, the duration, init duration, and all of those information. So cool. Now we have the report log processor in place. We store the data. That's fine. And finally, we need to display it. So we need another Lambda function to read this table and build a JSON. And what's happening is every day, a Lambda function will read this table that I've just shown and write it to data. So as you can see, 3 hours ago, data was written. And as you can see, this project is running for a bit less than 1 year. But every day, you have a JSON with the data. And 3 hours ago, a big JSON is here. So as you can see, the runtime data, one item for each runtime. So Node.js 18, Java 11, and so on. So this is like the bare bone data that the UI will be consuming. Any questions so far?
No, I think we're good. So just to recap, you basically have an orchestrated system that deploys a Lambda function per managed runtime, also for custom runtimes, and then you've created some functions in Go and in Rust to use those custom runtimes. You then deployed the Lambda function with 10 memory, well, a number, not 10, but a number of memory configurations. Run them. You force a cold start by updating an environment variable, and then gather all the data in Dynamo, and then that forms the basis of your of what you're gathering.
That's a perfect summary. This is exactly it. So and this is done like, I would not say easy, but like the architecture is like, I don't have to care about anything. Like AWS is taking of that for me. I don't need to like have waiting time before invocation. Like everything is event driven. Each Lambda function is receiving the configuration, invoke it. Then the report log line is automatically generated, produce an event. This event is coded by another Lambda function. So this is a power of serverless, like event-driven architecture. And I believe this is a great example of how we can use serverless like without worrying too much about architecture. So of course, I've made some choice, discutable choice. We can always improve, but it's working like that. And it's 100% serverless.
Oh, fantastic. So to hold sort of our lovely Lambda team to account and our lots of product managers, lots of amazing software engineers, obviously these init durations are going to change over time. So what can you sort of tell us about Lambda init durations over time? There must have been some sort of historical things where things have obviously got faster. Hopefully not too many ones when they got slower. But yeah, what's your impression of Lambda over time?
Maybe the best example is the Node.js 18, where when it was released. To be transparent, Node.js 12 outperformed Node.js 18. So it created a bit of noise about AWS is taking a bit of time to release Node.js 18, and when they did, the performance was not here for Hello World. So yeah, as we can see, like for today, 4th of July, the average is 175. But let's go back. This is live. I'm not sure what I'm doing here, but let's go back to 18. The average, I can't remember the number just before, but I believe this is much higher. So yeah, Node.js 18 definitely increased over time. I guess great stuff from the engineering team at AWS. But yeah, for instance, Node.js 18 was really not slow, but a bit slower compared to Node.js 12, and now it's way better. So, but that's a good question. One feature that I would love to put to make to this project is to have like a graph of historical data, because I have a lot of data for about 1 year, so could be great to have like a graph to see how every runtime is performing. So, but yeah, if someone wants to contribute in the chat here, feel free to open a PR, and I'll be happy to have a look at.
Yeah, no, that'd be great. And that's, I suppose that's also you indirectly highlighting one of the benefits of a serverless approach is that when you do pick a managed runtime, we are managing and patching and updating under the hood all the time.
Yeah.
And actually, Node 18 was an interesting example, because one of sort of, I don't know if it's a philosophy, but one of Lambda's things is we want you to be able to run your own native code, whether it's Python or Java or Node. We actually don't want to be messing around with the base managed runtime unless we need to do something specific for Lambda. And so we want to rely on the base runtime, because we want your code that if it's going to run on your laptop in a container, on an EC2 instance, on-prem, that you can be able to port that to Lambda and it's going to work without any sort of weird stuff. Now, obviously, we're using Amazon Linux too under the hood. So, there is some sort of dependency over there, but you can also use container images and then use any Linux distro if you want. But so,
no, I was about to say that's a good remark, and I have an open issue about like container. So I don't know where is it, but yeah, someone is asking to for a feature when I showcase the exact same stuff, but for containerized image in container. So
yeah, so that's interesting. So that's another whole sort of way to look at it, the difference between the cold starts for zip and the cold starts for container images. So yeah, I will actually come back to that. But the thing for Node 18 is the actual speed regression was actually part of Node. It wasn't something specific to Lambda. And obviously we test everything as much as possible for Node, but there is something, there was an issue within Node itself that needed to be resolved. And, Lambda is sometimes hesitant to go and make those changes ourselves because it needs to be part of the wider ecosystem. So, we worked out what the problem was. I believe it was some sort of some security dependency that had a regression in terms of performance. And so when that was upgraded in upstream Node, then we were able to take advantage of that and do it. So yeah, that's a tough scenario to be in, because people are going to say, hang on, my Node 14 and Node 12 is faster, Node 18 is slower. And you're like, well, sorry, that's just the way Node is at the moment. But luckily, when these things iterate, and as soon as Node is updated, literally your next cold start is going to take advantage of that performance optimization. So although this knowledge is useful, what is nice is behind the scenes, you're not having to go, Node 18 has been upgraded, so I need to then go and update my code. That's just going to happen behind the scenes.
Yeah, so this is exactly one of the big idea behind this project, is to have constantly up-to-date information. So I just want to wake up every morning and check, okay, this is I don't want to update the code. And actually this will lead to another part of the project, which is maybe I can skip a bit, but to maintain it. Obviously, for like compiled language, you can bring your own runtime, but obviously for Rust, AWS is providing a perfect runtime, Lambda runtime for Rust. And obviously this will need to be recompiled. And I don't want to go every day and look for every runtime, which dependency is about to be updated. So if we go to pull request, thanks to Dependabot, 5 hours ago, for instance, for GraalVM, URL connection client went from 2.20.93 to 98. And I just need to approve the PR and that's it. So yeah, Dependabot is a great tool. If we go to the configuration, Dependabot supports like NPM, but also Nugget for .NET, Go mode for Go, Maven for Maven and Gradle for Java, and even Cargo for Rust. So this is a lifesaver. At first, I was doing PR every day, like looking at every updates, and that's what's a nightmare. And it's not useful engineering time. So Dependabot is great for that, to be sure that every day we have the exact latest version for everything. So this is the whole point of the project, to have always up to date. Yeah. So maybe I can talk a bit about how to deploy that. So if we go back to Lambda Perf, there is I'm using serverless framework. I could have used CDK or SAM, but personally I prefer serverless. But it's just to show you that everything needs to be, as I stated before, needs to be like CI/CD compliance, because every time I want to add a new runtime or to test it, it would be a nightmare to deploy it manually. Yeah. So yeah, just make sure whatever tool you're using, just make sure you have a great CI/CD. So yeah, it's like 200 line of code, and it will allow you to deploy your Lambda function, schedule events. So every day at 2 p.m. The result will be built and published to GitHub. So yeah, make sure you have a CI/CD, and GitHub Action is great for that. You can create custom action. So if I want to deploy to AWS, I can do that manually, choosing a region. US East one is like the production one for me, and EU West one is the testing one, because I got some traffic now, so I need to be very careful when I do some change. And yeah, make sure you select staging and production. Staging and production means that the result won't actually be committed to GitHub. So yeah, I think that's it for maintaining. Yeah, yeah. If you have any question, but yeah, basically this is it. Just make sure you have a good CI/CD as any other piece of software you're doing. It's not because it's serverless that usually I already seen some people like going to the console and updating the code live. That's maybe good, but yeah, there's a lot of different tools to avoid doing that. It's useful sometimes, but yeah, if you want to have like a good feedback loop between the developer and the Lambda environment, make sure you're using the right tool to do that.
So you showed your CI/CD pipeline, but in a way, your CI/CD pipeline is not deploying the individual Lambda functions to run the test. It's sort of deploying the infrastructure, including that Lambda function, that then goes and deploys the Lambda functions to run the test. Is that my
yes? So if we go back, yeah. So these 5 Lambda function are the only one who stay there for a long time. So we have a result builder, which read because it does not change. It just read the data from DynamoDB and publish it to GitHub. We have the function invoker. So this 5 or 6 function is my like control plane, or I don't know, like
coordinator or orchestrator or something.
Orchestrator, that's fine. And then every other Lambda function, so things will change, is rebuilt every day. So as you can see, 60 minutes ago, I think this is non-prod, but yeah, it's the exact same for production, like 4 hours ago. If we go back, yeah. So things we need to change are deleted and recreated every day. But yeah, for something which does not change, such as reading DynamoDB, update it maybe when I do a big change, but not every day.
Hey, thanks, AJ. Yeah, and to have it all on GitHub and they have great deploy workflows baked into this project. Yeah. I love GitHub Actions as well. There's so many AWS integrations within GitHub Actions, and even from a security, ORDC support and all those kind of things, which makes it also super useful and helpful to use.
So yeah, actually, at first, of course, this is easy to say, like, hey, look, I have a CI/CD, but of course, like 6 months ago, I was doing like stuff pretty more manually, but as long as people want to contribute, they will need a way to test it on their own machine or their own account. And I got a lot of comments in issue, like it's too difficult to contribute. This is a good project, but it's hard to contribute. And no, as you can see, you just need to add like 1 item in the manifest JSON, 1 folder in runtime, and that's it. You can run it on your own account. So yeah, the aim is for this project to be as easy as possible to contribute, to fix. And actually, someone from the AWS drafted PR last week to improve the coldstart for Java. So thanks for that. That was really really awesome to see.
Excellent. So one other thing I was thinking about in this sort of orchestration piece is, some people are thinking about using step functions to orchestrate these kind of workflows.
Yeah.
Would that be an option in this kind of thinking,
Yeah.
a bit bigger picture, or?
Yeah, definitely. So I skipped this slide, but definitely there is room for improvement here because the orchestrated Lambda function are triggered by event bridge at a specific time. So function deployment will happen at 1 p.m. Function invoker like 45 minutes later. But what happens if the function deploy takes more than 45 minutes? So definitely room for improvement here. And as you say, step function would be like a perfect use case for that, because you can wait for like a state to be reached before going to the next step. So that's a very good idea. I will definitely look into that. Yeah.
Excellent. No, I think it's fascinating to see. I think there's so many different interesting threads to pull on here. In terms of just understanding cold starts, what we talked about at the beginning. How you can optimize them, reduce your dependencies, all of that. And then, this is a live tool. There's nothing AWS can hide behind to look at the cold starts over day. I know when I've looked before, the results have improved over time. So that also shows the benefit of using a serverless approach is that, under the hood, things are also getting updated. So that's a visibility aspect of the impact of cold starts. And then, yes, just this, this is a pretty big project, which is deploying a lot of serverless infrastructure, all in the CI/CD pipeline. But conceptually quite simple, but a lot of code in here to do it for all these different runtimes. And there's a lot of work that's gone into this.
And thank you. And I can show some example of how to improve. For instance, let's say you have a REST Lambda function, and it's like 3 simple line of code here for the release build. So in REST, when you compile your Lambda function, you can build it for debug or release. But you have some flags that you can put, for instance, code generation unit. When you build your Lambda function in REST, or like anything in REST, you have like code generation units, and it's like by default is, I don't know, it's maybe the number of CPU you have on your machine, and they're doing some local optimization on each one of those units. So let's say you have 4 CPU, they will do like some small optimization in those 4 blocks, and then building one unique block. But if you specify like, I want to use only one code generation unit, the compiler will take more time, so compilation will be slower. But since you're using just one unit, the local optimization is way better because you can improve. It's not depending on 4 boxes, it's only 1 box. So by doing this small stuff, you can reduce your cold start because the binary will be smaller. Of course, for Hello World, it's like maybe a couple of milliseconds. But for a huge application, maybe using this is great. And another one is panic, because for REST, when your code is panicking, you have a nice stack trace to unwind and to see what's happening. And sometimes you need it, sometimes you don't. If you don't need it, just strip the code out of your binary, and once again, your binary will be smaller. And if the binary is smaller, the binary will be faster. So yeah, it's just some example, and there's a lot of different optimization for every runtime. For instance, for Java, you can use the compilation tier to a specific flag to gain into performance as well. So yeah, everything is super transparent here. You can just browse every runtime and see what's happening here. But yeah, sometimes you, for instance, in the Lambda function in the Go, you forgot to strip out the symbol table, but the symbol table is useless in production. So the binary is bigger and the cold start is bigger. So it's small stuff, but it makes a big difference.
Yeah, so that's super helpful. I hadn't even realized all the little individual tweaks for different operating systems, different managed runtimes. And I know also, for example, you have, I think you've got Java as a managed runtime, and then I think Java running under Graal VM.
Yeah.
Same with .NET, the just-in-time compilation version of .NET. So you can actually literally compare the 2 different ways of deploying basically the same runtime, either via managed, either via custom runtime. Yeah. And then you can tweak some of these flags yourselves and see how it goes.
Yeah, exactly. Yeah. And yeah, feel free to fork it if you want more. Feel free to open a PR, but if you want to do like one specific test and trying another optimization level, you can just fork it, update that, deploy it on your own account, and see the diff. So yeah.
And I suppose one other tool I will bring in, it's not this tool, but it is the Lambda power tuning tool.
Yeah.
And that's funny enough, is a step function state machine. And then you give it your Lambda function, and you can give it an array of memory sizes to try, and it will invoke your function for each of the memory sizes and then compare cost and performance. And you can use a data-driven approach, literally look at the graph and go, there's the sweet spot for my Lambda function. So that's another tool, not quite for this deployment for doing cold starts, but managing cost and performance.
Yeah, and I saw there is support for. I saw a blog post on that. There's support for a new runtime is supported for Power Tool, right? I just saw something. I can't remember, but
yeah, I think what's come out recently. I think it is. About the Python, maybe Python 3.10. So yeah.
Okay, cool.
Yeah, actually, quick question. Sebastian Napoleon. Yeah, how much does this cost? Actually, cost you every month to run?
Yeah, actually, I can reshare my screen, but it does not cost anything. I'm still in the free tier, even if it's a lot of invocation, it's still under a free tier. So it does not cost anything. And I'm lucky enough to be into the AWS Community Builder community. So we got some free AWS credits. So if at some point I will exceed the free tier, I will use the credit, but it's entirely free. So if you want to fork it and deploy it, this won't cost anything.
Yeah, no, perfect. I mean, you get 1 million free Lambda invocations every month.
Yeah,
in perpetuity. It's not just for the free. It's not just a free tier for a year. It's forever. So 1 million of anything sounds really good. And
yes, something I would maybe do is, instead of 10 invocation, maybe 1,000 and 10,000 to have like a better mean, and I would stay in the exact same free tier. I guess this will cause some issue with the actual architecture, but maybe I'll do that sometimes.
Excellent. Well, Maxime, it's been fascinating to get a deep dive into cold starts, how you can profile it, tips and tricks on different runtimes. Huge amount of information, all available in one project. So thank you very much for putting it all together.
Thank you so much for having me, Julian. It was really a pleasure. And thank you so much for every question in the chat. That was great.
Definitely. Well, before we actually do say goodbye, just next up next week, if you are using SAM, we're going to have Mehmet, who's going to be going through the SAM remote invoke and doing a whole sort of series on Lambda testing. So that's going to be same place, same time on the 11th of July next week. And then a sort of quick reminder, serverlessland.com, everything about serverless on AWS, the new learning page. So, we in fact, last week I added a whole bunch of workshops. Workshops for me are one of the best ways to learn about serverless and understand different use cases. And they're things about for building web applications and do data processing and streaming, and a huge bunch of workshops. That's really really useful. And of course, EDA Day on the 26th of October. We'd absolutely love to see you there. And of course, all the code that's available on Serverless Land. So we've got patterns and step functions, workflows, and different repositories. So this is a great location of just getting hands-on code, because as Maxime showed, code can be king. It's going to be super good. And of course, to close out on, why is Bob not allowed? Well, happy Independence Day. Appreciate anyone from the US who's been joining us as well. Maybe you are watching the recording, maybe you're live. I know it's an important holiday for you. So really great to have you. So thanks, Maxime. Hopefully we'll be able to have you on in a future episode. Maybe we can get deep into Rust or deep into pizza. Who knows? Hopefully not Rusty Pizza, but that'll all be good.
Maybe both at the same time.
Exactly. I love it.
Maybe I can do something about pizza and the rest. And why not?
Excellent. Well, Maxime, thanks again for your time. And thank you to everybody for joining us. I'm sorry we didn't get to, there were some questions about AppSync and GraphQL. Sorry, Taruka, I didn't get a chance to chat to you, but offline or another time we can talk about that. So happy building, everybody, on serverless, and see you same time.